welcome back to another video with Indigo Math. Today I'm going to take you through some Trigo Proofs. Let's start. Moving on to the part B. Look at part B of the question. It says hence solve this equation. Every time it says hence, if you didn't use the answer from the previous portion, you wouldn't get the mark even if you get the final answer because the question specifies you to use part A. So we see here, if I want to use part A, I'm trying to see what's the similarity between parts A and B. So I've got cotangent square theta and the minus tangent square theta here. So I'm going to manipulate part A and make cotangent square theta minus tangent square theta subject of formula, then do a replacement. I'm going to continue this at the bottom. So in the part B, what we have is sine square 2 theta. I'm just copying the question first so I don't need to keep scrolling up and down. Cotangent square theta minus tangent square theta equals to 4 cos 2 theta. This is what I've shown in part A. And I'm going to make one of them subject of the formula. So what we have is, I want to make this subject of formula, right? So I know cotangent square theta minus tangent square theta can be written as 4 cos 2 theta over sine square 2 theta. So I'm going to replace this in my part B question. So what we have is, so I'm going to write down the question for part B. Part B says I'm meant to solve this cotangent square theta minus tangent square theta equals to minus pi cosecant square 2 theta. So this is what I'm meant to solve, right? And I see that I can just happily replace this whole chunk here with this fella. So I'm going to do that. It will give me 4 cos 2 theta over sine square 2 theta equals to negative pi cosecant square 2 theta. Seems like we've got a lot of triggers, but actually can I change cosecant square 2 theta into negative pi 1 over sine square 2 theta because cosecant is 1 over sine. So I'm going to just copy this portion down. And do you realize something? It's common, right? I've got this and this common. So actually, I can just look at the numerator and form an equation as such. So what we have now, we'll have 4 cos 2 theta equals to negative pi. My goal is to solve for theta, so I'm going to make cos 2 theta subject of formula now. I've got cos 2 theta equals to minus pi over 4. I need to go find basic angle. Please take note, when you find a basic angle, do not ever put the minus sign. The minus sign is supposed to tell you which quadrant it's in. Remember your ASTC 4 quadrants? So if I want negative, you need to be very mindful that negative of your cosine will only be in the second and the third quadrant that I'm going to mark out here. So let's go find basic angle first. So the basic angle, I'm going to call it alpha, will just be cos inverse of pi over 4, and that's going to give me, please remember to change your calculator to radian mode because this whole question is in terms of radians, so I get 0.66745. Okay, now I'm ready to go and see where my angles are. Remember in the beginning of the question, they did give you a range to solve for, right? It says I need to solve from 0 all the way to pi. But right now, your angles are in terms of 2 theta, so you need to go and adjust the range. Nobody's going to tell you, you are expected to know this. So I'm going to show you how to do adjustment for the range. If previously I had 0 to pi, now I need to change it from 0 all the way to theta to 4 pi. So you see what I did here? I just went to times 2 throughout. You are meant to go and adjust the range because it tells you where to stop when you're deciding which angles that you need to take in the 4 quadrants. So 2 pi means one whole round of the 4 quadrants. So that means one of my angles will be as such and the other angle will be like that. Okay, remember, basic angles is always the angle with reference to the x-axis. So I'm going to mark out where the basic angle is in black here on my diagram. So this is your alpha and this portion here is also your alpha. So now your 2 theta will just be pi minus away alpha and the other one will be pi plus alpha. Remember, your goal is to solve for theta. You need to go and divide throughout by 2. So eventually, what we're going to have is theta equals to pi minus alpha over 2 and a pi plus alpha over 2. Subbing in your value for alpha and pressing your calculator, you will end up with 1.24 and 1.90. Leave your answers to 3SF because it's in radian mode. Take note, if it's degree mode, your final answer should be to 1 dp. If not, I'm sorry, but overall your whole paper minus 1 mark because your accuracy is incorrect. That's that, we have come to the end of this question. So you see how in this question here, usually a proving question will follow up with a hence solve question, and you're meant to use the part A to help you with the part B. So if you want to find out more, come and join us in our September crash course and show you how to think about all these more challenging questions and also take you through some of these concepts and how we can apply them in the exam grade questions. That's that, and I'll see you in the next video with Indigo Math. Bye!